And our next speaker is Matthew Mack and colleagues.
Should I start now because it's not 5 yet? Okay. Hello, everyone. I am Matthew Mack, a postdoc here at the University of York. Today, I will be sharing with you our latest project on the retention of discourse memory across sleep. I would like to start this presentation with something relatively straightforward, paired associate learning. There is now a huge literature on this topic, and in this kind of task, participants first learn some word pairs, and afterwards they would be given the cue word and had to recall the other word. A lot of evidence suggests that paired associate learning is supported by the hippocampus, which binds the words together to create an episodic memory trace. We know this because patients with hippocampal damage have great difficulty learning this kind of word pairs. Another well-replicated finding in the literature is that these word pairs are typically better remembered after sleep than after wakefulness. This is perhaps due to sleep-related consolidation that helps strengthen the episodic trace of the word pairs. Building upon this literature and other strands of evidence from psycholinguistics, Gaskell et al. Proposed an episodic context account for language comprehension. It argues that when we comprehend language, such as upon hearing this sentence, the seal came up onto the bank of the river, episodic memory will bind the words in the sentence together, just like paired associate learning. And this would generate a context-specific representation represented by this picture here where a seal is coming up onto a riverbank. This representation is assumed to have a general purpose in facilitating online comprehension across sentences. For example, let's say this sentence, "it walks towards me," come after the previous one. We will know quite instantly that the pronoun "it" refers to the seal. And the episodic context account argues that this representation helps readers or listener to efficiently select the correct interpretation during comprehension. Furthermore, this account argues that if language comprehension soon followed by a period of sleep, the context-specific representation will be strengthened and stabilized by sleep-related consolidation as in paired associate learning. In contrast, for those who don't get a sleep opportunity, the context-specific representation may be prone to more decay. And after an equivalent amount of time, it is expected that the context-specific representation will be more robust and stronger in those who had a sleep opportunity. So to summarize, the episodic context account has two core features. The first one argues that during language comprehension, episodic memory binds words in a sentence together or sentences together, supporting the generation of a context-specific representation that can guide online comprehension. And secondly, this representation should be stabilized and strengthened by sleep-related consolidation. Based on these two features, it is predicted that memory for naturalistic discourse would be enhanced after sleep than after wakefulness. So here in this project, we tested this prediction by asking whether sleep benefits memory for naturalistic discourse. A few studies in the memory literature have actually tried to address this question, but unfortunately, the existing evidence base was small and inconsistent. For example, 2 studies showed that sleep benefits discourse memory only if the story had an emotional topic, such as murder, but not when the stories have a neutral topic. On the other hand, the study by Ali and Miskovich found that sleep benefits recall of neutral story. But more recently, a study with a much larger sample size failed to replicate the same benefit reported by Ali and Miskovich. One commonality between these studies is that they use free recall to tap discourse memory. Well, there's nothing wrong with free recall, although there is a key limitation. For example, let's say this is what participant read in an experiment. The parrot flapped his wings, then leaped into the air before remembering he wasn't a parrot, he was a squirrel. So afterwards, the participants may recall something like this. The squirrel thought he was a parrot and leaped into the air. He landed on the ground and was hurt. So it will be relatively easy for researchers to score the blue part because it had a lot of overlap with the actual story. However, the red part was not explicitly mentioned in the text. You can only infer from it. And typically, prior studies would discard this kind of inference or other types of errors from their analysis, losing a lot of data along the way. So what I'm trying to convey here is that story recall is usually very complex and nuanced, including details that may not be explicitly mentioned. And the kind of scoring protocol in prior studies may not be able to fully capture the complexity and nuances in discourse memory. With this in mind, we conducted a set of 3 experiments with different outcome measures, including sentence recognition, free recall, and cued recall. These experiments were pre-registered and they were conducted over the pandemic, so participants were recruited online via Prolific. This set of experiments represent the most comprehensive examination to date at the effect of sleep on discourse memory. Now let's start with experiment 1. In this experiment, we asked participants to first read 4 naturalistic stories with a relatively neutral topic. Afterwards, 12 hours later, which included overnight sleep or daytime wakefulness, the participants completed a sentence recognition task. 4 probe types were shown to the participants. The first type was verbatim, which was taken directly from the story. And the second one was paraphrase, which shares the same meaning as the verbatim sentence, but has changes in wordings. The third one was inference, which contains a proposition that was not explicitly mentioned in the text, but could be reasonably inferred from it. And the final one was wrong probes, and these contradict the story quite noticeably. In this task, participants simply make a binary yes-no judgment on whether they think a sentence appeared in the story they read before. If sleep benefits discourse memory, we may expect the sleep participants to give more yes responses to verbatim or paraphrases, but fewer yes to the wrong probes. Now for the results. The y-axis here represents the number of yes responses given by the participants. And for the verbatim and paraphrase probes, it is clear that the wake and sleep groups gave pretty much the same number of yes responses. And then for inference and wrong, the sleep participants seem to have a greater tendency to say yes to these probes. However, this difference was not statistically significant according to a between participant t-test, and the base factors are in the ambiguous region. So overall, experiment 1, here we found no clear evidence that sleep had an influence on discourse memory, at least not when recognition was used. And we speculated that this null finding may be related to the possibility that recognition may have a lower sensitivity to sleep-related memory effects than recall. Potentially, this is because recall and recognition require different neurocognitive processes, and sleep may be particularly beneficial for the processes that underlie recall, but not necessarily recognition. With this in mind, we switch from recognition in experiment 1 to recall in the subsequent experiments. In experiment 2, we decided to replicate a prior study by Ali and Miskovich. We chose this study because they had a small sample size, and as far as we can see, they are the only study in the literature that showed a sleep benefit in neutral stories. In this experiment, our participants listened to two short stories, like this one right here, and the scoring protocol was very well defined. You get 1 point for every single story unit you are able to recall. Some alternatives are allowed, so you will still get 1 point if you recalled Anne instead of Anna, for example. Following the general procedure of experiment 1, participants in this experiment heard 2 stories in section 1, A and B, followed by an immediate recall retrieval practice on one of them. 12 hours later, which included sleep or daytime wakefulness, participants recalled both stories. Now for the results. Here, the y-axis represents the number of story units correctly recalled by the participants. In section 1, the 2 groups performed similarly, and that's good because it tells us that the initial level of encoding was comparable between groups. And then in section 2, 12 hours later, recall performance was also very similar between groups, regardless of whether a story was afforded an immediate retrieval practice. So again, overall, in experiment 2, we found no evidence that sleep benefits free story recall. And this now finding challenges a prior study which used the same stories and scoring protocol, but had a substantially smaller sample size. Admittedly, this null finding is a bit disappointing, but it adds to the growing literature that the effect of sleep in declarative memory in general is smaller than what was previously thought. After experiment 2, despite the disappointment, we decided not to give up and to dig deeper by using cue recall to tap discourse memory. The reason for using cued recall is that we consistently replicated a sleep benefit in paired associate learning, which is a cued recall procedure. And this sleep benefit was replicated by our lab across hundreds of participants, and both in person and online. In light of this, we devised a novel cued recall procedure. So here in this experiment, participants first read 4 stories from experiment 1, and immediately afterwards, the participants completed a cue recall task where they were given sentence fragments like this one right here, and they were asked to fill in the blank using the word they think appeared in the story. 12 hours later, which included sleep or wake, participants completed cue recall again on the other 2 untested stories. Here, we are not only interested in whether participants were able to recall the exact words from the stories, we are also interested in how much deviation there is. Now, let me quickly walk you through the way we analyze the participants' response. For this particular blank, the verbatim word from the story was strengthen, and a participant may fill in the blank with strengthen, improve, fill, reclaim, so on and so forth. To analyze these responses, we had 2 scoring metrics: a subjective categorization approach, which assigned each response to one of the 4 pre-registered categories, and a more objective latent semantic analysis approach. For the interest of time, I will focus on the LSA approach because it takes a lot of time to go over both of them, but it's worth saying that the pattern of results from these two metrics were highly comparable to each other. So what we did here is we calculated an LSA cosine between each response and target and verbatim word. For simplicity, I would just say that this cosine is generally taken as a measure of semantic similarities. Two words sharing a greater cosine value are inferred to have more similar meanings. For example, strengthen and improve are quite similar in meaning, so the LSA cosine is quite high at 0.44. Whereas for strengthen and fill, the cosine is at 0.09. And this is even lower for strengthen and reclaim. So we use these values as a proxy to how distorted participants' response was. And then afterwards, we compare the wake and sleep group on the cosine measure. And immediately after story exposure, the mean LSA cosine were similar across groups. That's good because it again suggests that the two groups had a comparable level of initial encoding. And then in the second section that took place 12 hours later, the mean was higher in the sleep group. And this difference was statistically significant according to an encoder. We interpreted these findings as indicating that the degree of time-dependent distortion was lower after sleep than after wake. In light of this promising finding, we decided to test the generalizability by changing the mode of story presentation from visual to auditory in experiment 3B, and we kept everything else identical. And in this replication, we observed the exact same findings, again showing that LSA cosine was higher in the sleep group than in the wake group 12 hours later, suggesting that the degree of distortion was lower after sleep. So it was really good to be able to replicate our own findings in a different group of participants and across modalities. So to summarize this presentation, we used a couple of outcome measures, such as sentence recognition, free, and cued recall. And we use these to test whether sleep benefits discourse memory. We did not find the most consistent results, but that's science. And the answer to this question is dependent on how discourse memory was assessed. In sentence recognition and free recall, we found no evidence that sleep has a role to play. But in cue recall, we found some good evidence that discourse memory may become less distorted after sleep than after wakefulness. And how do we explain this pattern of results? We argue that sleep may consolidate or protect the binding between words experienced in the stories, but perhaps this benefit is quite subtle. And you need an outcome measure that is very sensitive to this small benefit. Our study seemed to suggest that among the three measures, cued recall was the most sensitive. Potentially, this is because the tasks require participants to recall the bindings between words from every part of a story. Whereas in free recall, participants may put in little effort and say, oh, I can't remember anything after the first sentence, reducing variability between participants. So this may partially explain why we found a sleep benefit in cued but not free recall. And finally, I want to highlight that recall procedures actually more ecologically valid than recognition in tapping discourse memory, because in real life, we are rarely asked to judge whether we had come across a particular sentence before, but we are often asked to retrieve the content of a conversation or a book. So in the context of tapping discourse memory, we argue that recall is actually more appropriate. To end this presentation, I want to go back to the theoretical framing for these studies, the episodic context account. This account argues that episodic memories binds words in a discourse together, similar to paired associate learning, supporting a context-specific representation that can guide online comprehension. And secondly, this representation is presumably prone to sleep-related consolidation effects. And these features lead to the prediction that memory for discourse should be enhanced after sleep. And our set of studies provided some support for this prediction. And that's all from me for today. Before I finish, I just want to say thank you to my supervisor, Professor Gareth Gaskell, Professor Jenny Rod, our research assistant, Adam and Alice sitting right in front of the audience, and the SLAM group at York more generally, and also thank you to the MLab organizer for this beautiful event. Thank you very much.
Okay, we have some time for questions. Yeah, please go ahead.
Yeah, hi, I'm Josh Hartshorn from Boston College. I thought the possibility that you just had a much better, like more sensitive analytic method for study 3 seems very plausible, and that was a cool analytic method. I was curious if you've thought about retroactively doing something similar to the first 2 experiments.
Mm-hmm.
Because actually I didn't follow, in the first experiment, was it for multiple, multiple answer forced choice, or is it a recognition where they shown like the sentences one at a time and asked for each one to recognize them or not?
Yes, I totally understand the confusion. So in the recognition task, each time the participants see one sentence presented on the screen, and is it okay if if I go back to my slides just for me to clarify? I don't know if I can.
Okay, no, that's all I needed to know about that. So that means that you could use use a sentence embedding to
Yes.
get and make those continuous as well, right? Have you thought about doing something like that to see if the effects would then emerge? For free recall, it'd be a little bit harder, but you could still do sentence embedding and look for, what is the sentence in the actual text that is closest to what was actually produced, and use that as the measure of their production.
Yes. So we haven't done word to fact that kind of analysis yet, but we did try to use LSA. And as you said, it is perfectly fine to use LSA to kind of get a sense of how distorted the free recall response was. So we basically compared the participants' response and the actual story, and we are able to generate an LSA cosine as what I've described, even though this is a document-to-document cosine. So the outcome, the results from this analysis is very similar to the scoring protocol that I described. So yes, I agree 100% that computational methods can provide us a very good way to look at this kind of data.
But did that end up giving you a significant effect when you did that?
No, it's very similar. It's basically the same as what we found.
Okay, thanks.
Thank you.
Hello, that was very interesting. Sorry, Aidan Zweig, University of York. That was very interesting. I'm curious, though, if you thought of an explanation which isn't kind of about the methodology, but more about the difficulty of the recall task, because the first 2 experiments required you to recall a whole sentence, right? But the third one required you to recall 1 word. And could it be that just the difficulty in recalling the whole sentence structure and all that was required in the first 2 tasks just basically was too much, so you're basically getting a floor effect and it's overriding the thing, and so it's not about the sensitivity of being able to see how it's done, but more just about you're just asking to do less.
Yes, that's totally possible. So for the first 2 experiments, I would say the first experiment is actually the easiest because you simply make a yes/no judgment. You don't need to recall anything.
Yeah, but in order to make that judgment, you still have to think, did I see that sentence? Not just, did I see the words in that sentence?
That's correct. So the level of difficulty is relatively easy for the first one because you can rely on familiarity instead of recollection. So I agree 100% that there is a difference in terms of what exactly we are tapping. There is a difference because for the final experiment, we are looking at words, but for the previous 2 is on the sentence level. So it is possible that there is a difference between the two kind of assessment, and we are trying to figure out why there might be, because the episodic context account argues for a sleep benefit on the discourse level, not just only the word level. So, so what we're trying to do here is to start with the discourse before going into the word level. But yes, we are still a bit trying to figure out why there is a difference there. Yeah, thank you.
very much.
Hello. Thank you so much for the fantastic talk.
Thank
so
you.
I had 2 questions, and they're kind of related. So one is more about your method, especially for experiment 3. So if you could just tell me a bit more about how exactly the exposure protocol worked. So the participants, you said they read the abstracts and then they heard them, but how much time were they given? Was there any repetition involved, and so on? And then after you answer, maybe I'll ask the second question.
Yes. So for the third experiment, the participants read or listen to the story just once. So you read or listen, hear the story in its entirety, and then after 4 stories, they will complete the Q recall task. And in the Q recall task, we took 16 words from each story, and then we always show. So basically, there are 16 trials for each story, and in the Q recall task, what we are showing is always 7 words surrounding the target word. So we don't want to give too much away, because if you give a lot of information, they can easily tell what that particular blank is. So we only show 7 words per trial with 1 blank. And there was no repetition at all. So everything was tested just once throughout the entire experiment. So story A, if it is tested in section 1, it won't appear in section 2, and vice versa.
Oh yeah, thank you. Yeah, I think I was more interested in how exactly they were exposed. So for example, because you said they read the text in their entirety, but how much time were they given? Was it that it was timed, for example, they had 10 seconds or whatever to read the story?
Oh, I see.
Or
I
was
see.
it that they could have all the time they wanted?
So for the reading experiments, it was self-paced. Everything was
I see.
self-paced. So each time they see a clause from the story, and then once they finish, they go to the next clause.
Okay.
But for the listening, it's slightly more demanding, because each audio was placed just once. You can't replay anything. So that's why we are seeing some deterioration in performance in the replication. So that's how we show our stories to the participants. So everything is very naturalistic. That's what we're aiming for.
Yeah,
Yeah.
yeah. Thank you. So, and now maybe to the second question, if I still have time. Maria. So do I still have time for another question? Yeah, okay. Yeah, so I was just wondering what your thoughts are about the importance of this exposure protocol. So I'm asking because in my experience, all those memory effects depend a lot on how exactly the participants are exposed to whatever they're learning. So I was just wondering if you have any specific predictions, like what could happen if they, say, had more time, or if they were also asked to read the stories and maybe, I don't know, explicitly told to memorize particular bits of those stories, or maybe if they were asked to produce bits of those stories, and so on and so forth. So what are your thoughts on this?
That's a good question. So what we have been doing is very incidental, very naturalistic reading. So what you have suggested is I would say an empirical question. So I don't have a clear answer to what we will see, but I can only speculate at this point. So my speculation is that we probably will see a stronger effect if we explicitly ask the participants to, I don't know, remember the story or pay attention to these words. So I suspect that this will lead to greater greater encoding strength. So you will pay more attention and effort into remembering the stuff. And as a result of this, sleep consolidation may prioritize this kind of learning because they may be more important for future. So there's some study showing that future relevance may be an important factor in sleep consolidation. So that probably would be my speculation, is that if you explicitly ask the participants to remember this thing, it will lead to greater effect of sleep.
Sorry, just the very last bit. How many stories did each participant have to learn?
Sorry?
How many stories did each participant have to remember or read?
Oh, so for experiment 1 and 3, they use the same story, so 4 stories for each of them. So they They are not short, they're about 500 to 600 words. But for the second experiment with free recall, they are very short, only 30 seconds in duration, because we showed them in auditorily.
Yeah, I just asked because I'm wondering what would have happened if you had amassed the participants with like lots of different stories, and then you would have tested the effects of what they had remembered in an incidental learning paradigm, because sometimes you find the effects are very different.
Yes. Yes.
Thank you so much.
Thank you so much. Thank you.
All right. So thank you for the